Hello, this is Jack Jackson. In this video, we're going to talk about selected Islamic mathematicians. Now, first of all, there are way too many, or way more at least, than the ones I'm going to talk about in this video. And some were probably as important or maybe even more important than some of the ones that I am going to go over. So I'm just going to give a few details for each of these. I'm going to leave out probably a lot of very important mathematicians from this time period and from this area of the world. So I would encourage you to go to the Mac Tutor History of Mathematics to see some biographies of many more Islamic mathematicians than the ones here. But basically what I've done is I've gone through pretty much every century and tried to pick out more or less one or maybe two per century of important mathematicians. Again, I'm not even sure that these are all the most important ones, but a few interesting ones for us to talk about a little bit. First one I want to talk about, as I talked a little bit about in the last video, is Alkarismi. Here is his full name, Abu Ja'far Muhammad ibn Musa al-Khawarizmi. By the way, this ibn is son of, so his father's name must have been Musa. Um, Interestingly enough, this picture here is from a stamp. This stamp is actually from the Soviet Union, and I pulled this from the Mac Tutor History of Mathematics. They have there an interesting collection of stamps with mathematicians' images on them from around the world. So some interesting things there. Al-Khwarizmi was born around 780 and died around 850, uh, either near Baghdad. And he definitely worked in Baghdad at the House of Wisdom. He was one of the first main scholars brought in there. And he was brought in specifically to translate earlier mathematics works, which he certainly did. He also wrote an important work on using arithmetic using the Hindu Arabic numerals. And most importantly, probably most importantly, he wrote the first algebra text. In fact, the word algorithm derives from his name, and algebra is derived from the title of one of his books. I think I mentioned the algebra, the book that came from his algebra text. That's where that comes from, and our current word algebra is there. Algorithm is actually um, a transformation of his actual name. Alkarismi somehow became algorithm, and an algorithm we know is a procedure for doing something. So in this case, procedures for doing algebra and procedures for doing arithmetic um, became associated with his name, which became morphed into our current word algorithm. So he's responsible directly then for two of the most important words, or two very important words at least in mathematics. He gives the purpose for his algebra as establishing a practical means of solving problems such as inheritance problems, partitions, trade, and other problems. So he set this up as a practical method. In it, he solved linear and quadratic equations. He had 6 forms of quadratic equations, and they were set up that way to avoid using negative numbers, whereas we might call them all essentially the same form today. He provided geometric proofs, but the techniques were algebraic, supposed to be used without having to draw any figures or do any constructions. So he gave algebraic type uh, formula manipulation, number manipulation kind of algorithms without having to draw figures. I'll mention again that the algebra that he had was not symbolic in our current sense of having, a variable like x or y standing for a quantity or a variable quantity, but rather things were written out in words. He extended laws of arithmetic to polynomials. He also did some other work outside of that. He worked on geography, extending what was known by Ptolemy. Remember, Ptolemy was known for, among other things, for creating some maps of the world, and Al-Khwarizmi was able to take those and extend them. He also did some work on astronomy, and we know for sure that he was using Indian sources for that. So he looked at some of the data collected by Indian mathematicians and astronomers as they were looking through their um, observations. And then probably he used Ptolemy's work as well. He is really probably should be known as the father of algebra because really he created the first algebra textbook. Now there's definitely some algebraic type of thinking going on before, certainly in this same area. Baghdad is just very near where Babylon used to be. And so um, this same area, there was some algebraic type stuff going all the way back to the Babylonians. But Al-Khwarizmi definitely lifted it up to a new level and more recognizable by what we would call modern day algebra. And more importantly, or well, I don't know if it's more importantly, as important, was he was one of the first ones to really kick off this renaissance of mathematical and scientific expansion there in specifically in the House of Wisdom in Baghdad. One of his immediate successors was Abu Kamil. Here is his full name, Abu Kamil Suja ibn Aslam ibn Muhammad ibn Suja. So you can kind of see some of his genealogy right there in his full name. But he was also called Ahasabi al-Misri. And once again, I apologize for butchering these Arabic names, which that translates as the calculator from Egypt. So we know he was from Egypt, possibly born there and raised there when he was younger. He was born around 850 and died around 930. He worked at the House of Wisdom in Baghdad. As I said, he was a successor of Al-Khwarizmi, and he wrote on algebra. He was able to take Al-Khwarizmi's algebra and expand upon it. He definitely credited Al-Khwarizmi with basically creating this field of algebra. And Abu Kamil worked on polynomials of degree higher than 2. He understood at least some laws of exponents, again, written in words. So for x to the fifth, instead of writing, first of all, didn't even write an x for the variable, and he certainly didn't write a fifth power, he would have called that square square root. For x squared times x squared times the root was just x. So x squared times x was x to the fifth. So he obviously understood at least a little bit about some laws of exponents there. He also wrote on surveying and geometry. He did some work on indeterminate equations. Now remember, a determinate equation is one that has one solution, but an indeterminate equation has at least more than one, perhaps infinitely many solutions. And he was able to do some work on those as well. And he's probably disproportionately important because his work turns out to be the basis for Fibonacci's books, and that is where we get a lot of the transmission of the Arabic work and even the Indian work and even more ancient stuff that have been transcribed and translated. That's where we get it going to Europe. So that connection to Europe that was important for the growth of mathematics in Europe comes by way of Abu Kamil, but several centuries later. It didn't happen while he was alive. Here's another one, Thabit. You can see his full name there. I'll spare you me trying to pronounce them. He lived from about 836 to 901. Again, worked in Baghdad. He worked on number theory, astronomy, and statics. He was multilingual, and because of that, he was very much valued as a translator. It's his translation of Euclid's Elements that turns out to be the basis for almost all the later, at least Arabic translations and maybe other translations as well. So, as important as Euclid's Elements is, we still owe a lot to Thabit because it was through his translation that it got preserved. He also, in his own work, extended the idea of numbers to include all positive real numbers, and he introduced operation on numbers and didn't force them to be interpreted as geometric measures. So by this time, we're starting to see a stepping back from forcing everything to think of as um, geometry, whereas the Greeks would have looked at a square of a number times itself, as actually representing a physical square. By this time, Thabit is starting to think of that more as just a number times itself, separate from a geometric interpretation. He also did some work on trigonometry and spherical trigonometry, number theory. He did some work on amicable numbers. And he worked with parabolas and hyperbolas and paraboloids and helped lead to later development of some integral calculus. He wasn't really doing calculus per se, but the work that he was doing with parabolas and paraboloids uh, helped to generate some interest and some ideas that were later to grow into integral calculus. Definitely one of the most famous and most prominent of the Islamic mathematicians is a guy that is known in the West, at least, by the name Omarkayam. Probably more correctly, we should call him Alkarismi. And here is his full name. And it's interesting, the word, if you do a literal translation, Al-Kayami means tent maker. So that might just be a family name, that he came from a line of tent makers. He may have, I'm pretty sure he wasn't a tent maker by profession, but at least not permanently. I want you to look at his birth and death dates. For the first time, I've put an exact date. I think this is the first time I've done this in these notes. May 18th, 1048, May 18th, 1048, to December 4th, 1131. These all the date now are in the Common Era, so I'm going to drop the CE from here on out in the course. He lived in Nishapur, Persia, so he's actually a Persian mathematician. And it turns out that he was really known, probably at least as famous, or maybe even more famous than as being a mathematician, was as a poet. He's one of the greatest Islamic poets. But he's also actually known for his mathematics, and some folks would say his mathematics is actually more significant than his poetry, but he's known for both. Here's an artist rendering of him here, and then this photograph at the bottom is his mausoleum, so that's where he's buried. Seljuk, not sure if I'm pronouncing that right, Turks, founded an empire which included Mesopotamia, as far out as Syria and Palestine, and present-day Iran. And they tried to establish an Orthodox Muslim state, so this became a pretty difficult time for scholars. And it was during this time of turbulence that Omar Khayyam, or Al-Khayyami, that he lived. He eventually moved to Samarkand, and that's in present-day Uzbekistan, and set up an observatory. So the observatory was for, observing the sky, astronomy. He there created astronomical tables. He worked on calendar reform, and he gave an astonishingly good estimate of the length of the year that was accurate to many, many decimal places. He wrote several books, including books on poetry, books on mathematics. One of them was a treatise on demonstration of problems of algebra. He gave geometrical solutions to cubic equations via a hyperbola and a circle where they intersected, and said it can't be constructed with straight edge and compass, which turns out to be true for the particular equation that he had, but it wasn't proved till a century later, and the proof actually required some use of some abstract algebra. He translated geometric problems to algebra. And among other things that he did some work on geometry, and he attempted to prove Euclid's parallel postulate. And in the process, he developed several theorems that we know are true in non-Euclidean geometry. Of course, proving the parallel postulate was doomed to failure because it's actually independent of the other postulates. So there was no way he was going to prove it, but along the way he developed some interesting things that were picked up on by later European mathematicians, much later, several centuries later, when they actually finally came up with hyperbolic geometry and non-Euclidean geometry. Next, we're going to talk about AlTusi. There were a couple of AlTusis that were important. This one is Nasir al-Din AlTusi. He was known actually by several different names. I think his official name should have been Muhammad ibn al-Hasan al-Tusi. We know he was born on February 18th, 1202, and June 26, 1274. So notice that with Khayyam and AlTusi, we actually know the exact date that they were born, not just approximations. So that's a kind of an interesting thing that we haven't done before this. He was born in the region of Tus, near Baghdad. So AlTusi means from Tus. That's again a region near Baghdad, and there was quite a bit of conflict in his time. The Islamic Empire had spread nearly all the way to China and even took over parts of Eastern Europe, but the Mongols under Genghis Khan invaded, and they weren't very nice to the Muslims. They actually massacred quite a few of them. And Genghis Khan was actually uh, one of the most successful military leaders of all times and conquered the most territory of, well, I think anybody. I think the his empire really, in terms of just physical land geography, was the largest in history. He worked. AlTusi worked in Nishapur. He did work on logic, philosophy, mathematics, astronomy, and ethics. And it's interesting when the Mongol army or whatever came in, AlTusi felt like they were going to win, so he actually joined the conquering Mongols, and it probably saved his life, or at least it made his life nicer for him, so he was able to keep some sort of position there. He constructed an observatory at Merga in 1262. So Chinese astronomers assisted the Persians there in building that observatory. This also became a center of learning. So it's not just an observatory, but a surrounding community of scholars, a school, if you will. Major contributions to astronomy, including a collection of 12 years of accurate observations, were made by AlTusi and the other astronomers there. There's something, a theorem that he's known for. It's called a Tusi couple, and it's used in resolving linear motion and the sum of two circular motions. And his commentaries on Greek works include the Alkarismi. He made trigonometry of fields. He helped lead a revival of the Islamic sciences. Here is some side-by-side of some of the work of Tusi and Copernicus. And I'm sure you can't read the different languages that are here, but just looking at the figures, you can definitely see some similarities in these and working with what's called a Tusi couple. And so there's a good chance, high degree of chance, that Copernicus had actually read Tusi's work and worked on some of this. Eventually, Copernicus abandoned this geocentric model in favor of his heliocentric model of the solar system. The next one I want to talk about is Ulugbek, skipping ahead a little bit in time to 1393 to 1449. This guy's kind of interesting. He was born in Timurid, Persia, and he worked and died in Samarkand, which is part of the Timurid Empire. That's currently in Uzbekistan. So he was the grandson of the Mongol conqueror Timur. Timur was called Timurlane by some of his foes, actually. So Timur conquered what's now Uzbekistan, Iran, Iraq, and eastern Turkey. His farthest expansion and even included parts of India, China, and Syria. And Ulugbek traveled with his grandfather's army, so he got around to a lot of different places. His father, Shah Rukh, gained control over most of the empire after Timur's death. And Beg was given Samarkand to rule, so he was actually the ruler of this city underneath his father, the ruler of the empire. And he decided to make it a center for learning. He was a scholar himself and a mathematician and astronomer himself, but he also wanted to have a center there to attract others. And so this observatory and madrasa, which was a school or university school center for learning, was established around 1428, and it fell into disuse after time and was later restored and excavated. But you can see a picture of what it looks like now, and this is the observatory uh, there uh, in Samarkand. And this area, the observatory and then the school is with it, became a major center for learning at that particular time, particularly a center for astronomy, trigonometry, and spherical trigonometry. And he and the fellow scientists there developed a star catalog, and they tracked many, many stars. So he's very important not only for his own work, but also in supporting the work of others. Probably his lead um, mathematician and astronomer at that time was Kadizada. Another one was Akashi. They were contemporaries. So the three of them, Kadizada, Alkashi, and Beg, were the top three scientists there out of many at this. His Kadizada here's his actual real name, which doesn't have either one of those words in it. Right there, Kadizada means son of the judge. So apparently his father was an important judge. He lived from 1364 to 1436. If you notice, that makes him a little bit older than Beg. And he actually was brought in and actually was Beg's teacher. He was born in, Zada was born in Bursa, Turkey. He worked and died in Samarkand. Again, that's in present-day Uzbekistan. One of the primary mathematicians and scientists at the observatory there, and among other things, he made very accurate sine tables. For example, he found the sine of 1 degree accurate to 12 decimal places. That's an amazing amount of physical calculation without any kind of calculators to help him. Okay. There was a star catalog put together by the scientists there in the observatory, most significantly Zada, Alkashi, and Beg, and it included positions of 992 stars. It was published the year after Zada died. And again, Alkashi was the other major contributor to that. So once again, that's just a selection of a few of the most important mathematicians. I'm sure I left out some that were probably equally important. And there are many, many others as well. So I encourage you to look to your textbooks, to the Mac Tutor for a list of some other prominent mathematicians of this culture and this time period, and you can find more about their individual histories there. But this will give you a taste of at least some of the most important ones. And I believe that's probably going to conclude my work on Islamic mathematicians this unit. And so next week we'll be talking about what's happening in Europe at this time, and after that will kind of conclude our second unit of the course.